Okay, so let's look at our assignment number 5. The problems that we see here are at the end of this chapter on belts and chains, which is chapter 11 in our book. So let's take a peek at each one of the problems that we have assigned here. I'm just going to circle them right now in my book. So we've got 2 and 6. We've got 8, 12, and then we've got 18 and 20, 22 and 26. Okay, so let's take a look at these at the end of our chapter. These start on page 313. So I'm going to go underneath. And the first problem that you have here, you're going to notice that it starts with a heading of this is belt kinematics. So the first part here says we have a motor operating in a clockwise direction at 1150 RPM. It's coupled through a belt drive to rotate an industrial exhaust fan. The diameter of the motor sheave is 5 inches and the sheave on the fan is 12 inches. So this is belt drive stuff, okay? Determine the speed of the driven sheave and the belt speed, okay? So this is a W and this is a V, all right? So those are the two things that you're going to calculate for that one. You don't have to go through the whole business. So you're going to focus on W for the driven sheave, so W2, and then belt speed is going to be a VB, all right, given with that information. Number 11.6, same type of a problem. You're going to notice that I'll let you read it. I'm not going to read the whole problem, but it says determine the required speed of the engine sheave. So that's going to be a W2 again, and a belt speed of VB, okay? Oh, yeah. This is a W1 because W2 is being given here. That's the output. Thank you. Okay. Then you're going to notice we're going to go up to the next one. This one's going to be a belt drive geometry. So for this one, we've got 2 sheaves. They have a diameter of 5 inches and 12 inches. Determine the center distance of the drive utilizing a 72-inch belt and compare the center distance to the ideal range. Okay, so remember that range equation and see if you land within that. Also determine the angle of contact or the angle of wrap over the small sheave. That's going to be the theta 1. All right. Number 12, we've got a belt drive. It's desired to couple a motor with a mixer for processing corn syrup. A 25 horsepower electric motor is rated at 950 RPM, and the mixer must operate as close to 250 RPM as possible. So they're not saying it has to be exact, but you want to be nice and close. Select an appropriate belt size, commercially available sheaves, and a belt, so that's with the length for the application. Also calculate the actual belt speed, that's VB, and the center distance, C. Okay. So 1, 2, 3, 4, those are going to be your belt problems. All right. A couple smaller ones. And then this one's going to be more like that last, full blown. Then we're going to go to problem number 18 and number 20. These are going to be the chain kinematics. So this one, I'm not going to read the whole problem to you, but you want to determine the speed of the driven sprocket. So that's going to be a W2, the chain speed, VC, and the recommended lubrication method. So remember, when we have a chain speed, it's going to be either slow, moderate, or high speed. You want to pick either manual, bath, or drip. Okay. Number 20, same type of a problem. 22. This one, you're going to determine the pitch diameter of each sprocket in the description, their center distance, and the angle of contact over that smaller sprocket. And then also compare that center distance to the ideal range that was given. And then the last problem you have is going to be number 26, and this is going to be the drive selection. So this is going top to bottom like that last problem that we did. So you want to select an appropriate chain size, commercially available sprockets, number of links in the chain, and then also calculate the actual chain speed and center distance. Now, on these last problems where you are doing the full design for either the belt or for the belt and the chain drive, you might get a little bit different answer than if you compare to somebody in class. Because remember, when we were reading that, you know, which size belt should I use? I would have gone up to the 50. All right, the number 50 chain. They stayed at the 40. So it's not wrong to stay at the 40, but as a designer, you guys all might have a little bit different idea of what you want to do. Does that make sense? So it's not necessarily going to be a hard and fast, this is what it is. Because there's multiple options that it could be that'll still have a safe design. All right. So that's your homework assignment. There's no AutoCAD to do here. There's no, you know, things to draw out, but you do need to go through the calculations neatly. Make sure that you're kind of following all our rules that we have with equations in variable form first, put in your values with your units, cancel, combine as needed, final answers, all that kind of stuff. Okay. So, so that's homework. Any questions on that? All right. If not, then I'm going to stop the recording.